Welcome back, everyone. Let's jump right in and take a look at section 9-6. First thing we're going to take a look at is theorem 9-9, which says that the measure of an angle formed by two chords that intersect inside a circle will be equal to half the sum of the measures of the intercepted arcs. So let's take a look at this diagram just to wrap our heads a little bit around what this is trying to describe to us. So in this diagram you can see we have chord CE intersecting chord DB. And that's what the first part of this theorem describes to us. Two chords intersect inside a circle. Now when those two chords intersect, they're of course going to form four different angles. Let's imagine for a second that this is the angle we wanted to figure out. Let's call that angle 1 right there. According to theorem 9-1, angle 1 would have a measure that is equal to half the sum, and remember sum is what you get when you add two things up or add a number of things together. So it's half the sum of the measures of the intercepted arcs. Well, what do we mean by intercepted arcs? Well, we have to consider the fact that angle 1 right here intercepts arc CD. Its vertical angle, which would be over here if we wanted to call that angle 2, we know that these vertical angles will be congruent, and angle 2 intercepts arc BE. So according to theorem 9-9, what we would have is that the measure of angle 1, which would be equal to the measure of angle 2, either one of those would be 1/2 of the measure of arc CD plus the measure of arc BE. If we wanted to throw some numbers into here to kind of get maybe a little more concrete idea of what we're talking about, we could imagine that, let's say arc CD has, I don't know, let's say that has a measure of 50 degrees. And let's say arc BE has a measure of, let's say, 120 degrees. Then angle 1's measure would be half of 50 plus 120, which would mean it's half of 170 degrees, which would mean that it's 85 degrees. So angle 1 would be 85, and that would be the same as angle 2 because they're vertical angles. So that's the idea in theorem 9-9. Now in theorem 9-10, we're going to be looking at a slightly different scenario. It says the measure of an angle formed by two secants or two tangents or a secant, I messed that up, let me rewrite that, a secant and a tangent drawn from a point outside the circle is equal to half the difference, not the sum here, half the difference of the measures of the intercepted arcs. So you can see I'm going to have to look at three different diagrams for this theorem because it describes three different possible scenarios. In this first diagram, right, we'll call it diagram A, we have two secants of this circle that are meeting at this point here outside the circle. In diagram B, we have two tangents of the circle meeting at this point. And in diagram C, we have one secant meeting one tangent at this point right here outside the circle. So what is theorem 9-10 telling us? Well, for diagram A here, we would be able to say that the measure of angle 1 would be half of the difference, meaning we're going to subtract the two intercepted arcs. So we would take x degrees minus y degrees. And if I subtracted those and then took half of that difference, that's going to be the measure of angle 1. So if we wanted to put some numbers on this to get an idea, we might say that let's imagine angle x here to be 110 degrees. And let's say angle y here is, I don't know, let's say it's 60 degrees. I don't know how accurate that is for what the picture shows, but let's imagine that those are the two intercepted arc measurements. Then angle 1 measure would be 1/2 of 110 minus 60, which is half of 50, which would be 25 degrees. In diagram B, where we have our two tangents meeting, the measure of angle 2 would be half of, again, our two intercepted arcs subtracted from one another. So the arc with m degree measure right here minus the n for this arc's measure right here. So again, if we wanted to put some numbers on this, let's say that arc M has a measure of, let's say, 280 degrees, and let's say that the arc with the n degree measure, let's say that n is, I don't know, 140 degrees. Nope, that doesn't work because these two would need to add up to 360 because basically we're encompassing the full circle. So I need to pick another number for n. If I use 280 right here, I would have to use, let's change this to 250 degrees, and that would mean that this is 110 degrees. These two add up to 360, which they should because these two arcs together are making up basically this full circle. So in any case, angle 2 now would be half of 250 minus 110, which means it's half of 140 degrees, which would be 70 degrees for angle 2's measure right there. Lastly, in diagram C, we have the secant and the tangent meeting right here, and that would mean that the measure of angle 3 would be half of the A measurement, this arc's measurement, minus B, which is this other intercepted arc's measurement. So as a way of kind of an example, let's imagine that arc A right here, which looks to be maybe that's 200 degrees, and let's say that B is, let's say that's 95 degrees. Then angle 3 would be half of 200 minus 95, or half of 105. Half of 105 would be 52.5 degrees. Angle 3 would, in this case, be 52.5 degrees. And so those are the two theorems that this section is going to present to you. So now, I want you guys to try example 1 and example 2. Example 1's a little bit trickier. I think maybe example 2 is a little bit easier, but you can give it a try and input your answers into the box that should pop up, and let's see what we get. Okay, let's look at example 1. In the diagram below, segment EB is tangent to the circle, and angle BEG will be 30 degrees. So first of all, it asks us for arc BH. So here's arc BH. It's one of the arcs intercepted by this angle right here, which is kind of like diagram C that we just went over. It's an angle formed by a secant and a tangent. So we know that this 30-degree angle had to be half of the difference between 92 and arc BH, the measure of arc BH. So now if we think of this like an x, we should be able to use a little bit of algebra to solve this. First of all, I'm going to get rid of this 1/2 by doubling the 30. If I multiply this side by 2 and this side by 2, in other words, if I take 2 times 130 and 2 times the 1/2, then the 1/2 will be gone, and that'll be a 60. So now I have 60 equals 92 minus, I'm going to just say x instead of the measure of arc BH. Now, using a little bit more algebra, I can figure out that if 60 is equal to 92 minus x, then x must be 32. So arc BH right here is now, we know, a 32-degree arc. The next thing it's asking for is the measure of angle BGF. Now, BGF is one of these angles formed by a couple of intersecting chords. So we're actually going to be using theorem 9-9 to find this angle's measure. We know that this angle, or its vertical angle right here, would be equal to half of the sum of the two arcs that are intercepted by those two vertical angles. So it would be half of 108, because that arc is intercepted by this angle, angle HGD. So it's half of 108 plus the 92 that's right here, because that is the arc that's intercepted by angle BGF. So it's half of 108 plus 92. 108 plus 92 is 200. Half of 200 will be 100 degrees. So I know that this angle, angle BGF, has to be a 100-degree angle. The next thing it asks for is angle DGF, right? Angle DGF. So the easiest way, and there's a number of ways you could perhaps find this angle's measure, but I just look at this straight angle right here. DGB is a 180-degree straight angle. If this part of it's 100, then this part of it over here would have to be 80 degrees because they need to add up to 180. So I know that that's 80 degrees. Now next we have arc DF that we're supposed to find, and we're going to be back to theorem 9-9 here, because I know that this 80-degree angle, that 80-degree angle has to be half of arc DF's measure of arc DF, plus this arc's measure BH, which we already found to be 32. So it's half of DF plus 32. Again, I'm going to get rid of my 1/2 by multiplying it by 2, but if I multiply over here by 2, I got to multiply over here by 2. So now I have 160 equals, this is gone, and I'll just put an x here for my measure of DF. X plus 32, little algebra, subtract by 32 on each side, and I get 128 degrees for x, so I get 128 degrees for arc DF right there. Next up, we got example 2. It says if segment AD and BD are both tangent to the circle, and the measure of arc AB is 105, then what is angle D's measure? So let's go ahead and write in, we got 105 degrees right there. Now we know that that's one of the arcs intercepted by this angle formed by two tangents. The other arc would be arc ACB, this major arc right here. Well, do we know what that arc's measure is? We kind of can figure it out, right? Because if this is a diameter going through the center of the circle, then arc AC would be 180 degrees. But so would arc ABC right here. That would also be 180, but 105 of those degrees is used up for this arc, so that would mean that there's 75 degrees left for arc BC. So if I wanted to find the measure of angle D, I know that it's going to be half of the difference between arc ACB. Arc ACB has a measure of 180 plus 75, which is 255, minus arc AB, which is 105. So now I just got to do a little arithmetic. That's 1/2 of 255 minus 105 is going to be 150 degrees, and half of 150 should give us 75 degrees for angle D. So that's it for this video, and we will see you again for the next section. So good luck.